Hello, this is Ian Eubanks. This is lab 1 for logic design. And just to start off, here's my ID. Ian Eubanks. This is me. All right, so to start off with lab 1, this is my truth table. We have the 4 inputs A, B, C, and D. And we have all the instances of these 4 inputs. Here are the 2 equations for the inputs, B bar C, then or B bar C or A D bar. And this equals the output of X1. And then we have B plus A D bar equals the output of X2. So we implement this equation over here. This is obviously input 1, A, B, C, and D, and then these are the knots. And then we have these connected to it. And these go to, so this is B bar C, the B bar C, and this is an AND gate. So, it's just gonna consider both of these inputs. Whatever is considered, that'll be the output, and this will be displayed in the OR gate right here, which here represents these pluses. So 3 inputs into the OR gate, and that will output X1. And the same is for X2. We have B plus A D bar. So I just took the output from A D bar and put it with B, and with just with B. And hold on, let me switch this. This is just straight B. Oh, this is B bar, my bad. This is straight B bar, and my apologies, but we didn't need that NAND. So this is B bar, and then A, and then D bar. So D bar, and then we have just straight A. All right. Here are the connections for the pins. As you can see, this is my whole diagram. It's a little messy, but I'll show it just for a while so that you can see. And I didn't put X2, but I can go ahead and put that. X2, and then AD. Where's B bar? B bar. It looks a little convoluted. And then AD. AD bar. So it's this right here. That's X2. And so right here is the actual circuit. All right, so I'll flip this on. And as you can see, all of my lights turn on. So originally I just used these 2 LEDs. I could have spaced them out more, but I just decided to use these. This is, I believe, goes to the X1, and then this one is the brown wire is to X2. Yep. And so basically, as you can see, all of the instances of the circuit work. So how I labeled it was, this is A, B, C, and D. These are my outputs, so they're all off now. So when all of them are off, as we can see up here, X1 and X2 are 1. So let's do when both are on. So when B is 1, both lights should be off. So B1 off. All right. And then to turn these back on, we need all of them off. So let's turn all of them off for the next instance of X1 and X2 to be on. So we'll turn A, we'll turn B, C, and D off, and then leave A on. So turn this off, then leave A on, and the lights are still red. Now we have just, and then, well, we can try all these instances. They all work, but this is just basically, they're both the same output, of course, essentially. So they will both of the lights will be on at all periods. But I just want to show you like just the different range of working of both of the inputs working. So then 3, A, B, and C are on. A, B, C are on. If it turns off when D is on and C is off. And also C, excuse me, just different combinations. So A, B is on, C, D is off. Let's see what that is. A, B, C, D, on, 1, 1. All right, my circuit seems to be working, and this concludes my lab 1.